Hi, this is Calvin Cox. It is Sunday, September 29, 2013, and it is 12:04 in the afternoon. And I couldn't help but try this idea because it's got to be doable. The person that can do this, I don't know what they're going to come up with, but it's going to be something very, very interesting. But you're going to need a laboratory to do it. You're going to need something that can separate antiparticles out of standard matter. But what you'll come up with, I haven't been really able to dwell on it very much. It takes time to digest things, but this is so unusual. But in theory, it's completely possible. So anyway, I'm going to throw it out to you, and I hope you'll enjoy it. You might go, whoa. I mean, that's what I did when I thought about this. But let me get on this side. This presentation is called Making a Proton Coil. Okay? With current arrangement of matter, the way it works for the conduction of electricity, and electricity being electrons. Okay? How it works is you have like a standard atom has a positively charged center called a proton, and if there's more than one proton in the middle, all the conglomeration of all the positively charged protons is then called a nucleus. But the electrons, which are negatively charged around the positive center, have a natural attraction to come into the center and join with the positive, because opposites attract, just like if you have two magnets and one is a negative charge and one is a positive. If you get them near each other, they'll pull together. The same thing occurs around the center of atoms, is that the first shell electrons, and actually all the electrons, want to pull into the center. Well, they can't. The first shell electrons, my belief is that they're held away by an antiparticle that acts as, like if I were the positive center and this was an electron out here, it's kind of like an arm that sticks out, and it keeps the electron from pulling in. Okay? And that's what I believe the antiparticles do. Now, that's for the first shell electron, and maybe even for the second shell electrons. But for the other shells, what keeps those electrons from moving in, migrating in, is that likes, they don't attract, they repel. So if you have a bunch of electrons, they want to pull into the positive center of the atom, the nucleus, but because the electron forces themselves, once they go but so far, they will not go to each other. They repel each other. So opposites attract, likes repel. So I believe from the first or even second shell, the other shells out to the outer shell electrons, they want to pull into the center, but they can only go so far because the other electrons are in the way and they're repelling them. So that's my view of what a standard atom would be that is like stable, in a stable condition. Okay? It's not heated up where it's a liquid, it's not cooled down to -0, where other bizarre properties start to happen. I think it's -450 degrees Fahrenheit is supercooling to absolute zero, somewhere down around there. Don't quote me exactly. I don't have all day to look up precise, amounts. And then the outer shell electron is like free to move. If it's in the right configuration, it's very free to interact. You probably know all this. You've heard it in basic classes in high school. Now, I believe you can alter this current situation to an altered arrangement and come up with a proton coil. The trick is, okay, let's say this is a copper wire under your current arrangement, and on the surface of that copper wire you have the outer shell electrons, that are all there, and they're able to jump when there's an excess amount of electrons. Current only occurs when there's an excess amount of electrons, which would be voltage built up, and it creates pressure. And so excess electrons will then flow to a lesser pressure. They flow from higher pressure, a source of a lot of electrons, to a lesser source, a lesser pressure. Okay? Now, so if you take this standard wire and then you come down here, we're going to show you an altered arrangement, okay, and you introduce to the exterior of that wire, of that copper wire, you're going to have to introduce, okay, you have an antiparticle here. So what you're going to do is you're moving an antiparticle to the outside electrons, okay? So let's say this copper wire, you had the outside electrons up here. What you're going to do is you're going to move these little, I have like little straight lines representing the antiparticles. You're going to take a piece of copper wire and put it in a source of antiparticles and coat that copper wire with antiparticles, and then you would coat it, take that same wire you just coated with antiparticles and put it into a source of protons, okay? And in theory, the protons would be attracted to the electrons that are on the outside of the copper wire, but if it worked like I think it would, the antiparticles would hold the protons from going and joining with the electrons. Okay? And then, from that point, if you could provide another source of excess protons and put them on that wire, those protons would then want to flow to a lesser source or a lesser charge of protons. So it's like coating a standard wire with antiparticles to allow you to coat it with protons. Then, if you could again supply an additional source of protons, those protons would tend to flow. And then, if you were to take that wire and coil it into a coil, okay. Let me see. This is we'll say proton coil. Okay, now this is an electron, like your standard coil, electron coil. Okay, the electron coil creates magnetic fields. Okay, the proton coil, I believe, would create a field, but I don't know what it would look like. I haven't even gone that far in my own mind to try and figure out what you would get. But it's quite possible. I'm sure it's going to create some sort of field, but I have no clue what it would look like. And so therein lies a very unusual but very possible situation to look in that might have a rather profound effect on, possibly, might have an effect on physics. If you could isolate antiparticles, coat a copper wire, then introduce free protons that are not bound to anything, and then introduce excess protons, and those excess protons would repel from each other, just like an electron repels from other electrons. The protons would repel from another proton. Therein lies a very interesting and very possible thing you could do. Now, they're supposed to be able to separate antiparticles. And if you took a little tiny wire and a little tiny coil, because you could only get a super small amount of antiparticles, and you were to do this, and then you had it set up to see what kind of field would be created, I'm more than sure it would be incredibly interesting. Thank you.